Hello, NCA Level 2 Physics. Today's lesson will move on from the kinematic equations we learnt last week into the wonderful world of forces. In fact, Newton's laws. So Newton's laws come in three forms, which we're going to now go through in some detail. The first one being rather imaginatively called Newton's first law. So what that says is that an object will remain in a state of constant motion unless acted on by a net force. Now when I say a net force, we have this vehicle here and we have, say, a friction force acting on it and a thrust force acting on it, and the sum of these two forces, if they equal zero, then acceleration is equal to zero. Okay, so this means that in theory an object can travel forever at constant velocity. However, as the diagram illustrates, in practice in the universe there will always be some sort of friction to slow the vehicle down, be it this wonderful Ferrari that I own, or the USS Enterprise from friction from, say, interstellar dust. So looking at Newton's second law, it states that an object's acceleration is proportional to the applied net force and inversely proportional to its mass. So writing that as an equation, we have force is proportional, that's the symbol for proportional, remember, to the acceleration, and the acceleration is proportional to 1 over the mass. So here we have an object of a mass. You can see its force and acceleration. So an increased force will produce an increased acceleration because force is directly proportional to acceleration. Whereas an increased mass will produce less acceleration for the same force because acceleration is proportional to 1 over the mass. On the next slide is a short video illustrating this on the moon.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
So looking at in further detail, the Newton's second law can be represented by an equation where force equals mass times acceleration, where force is in newtons, acceleration is in meters per second, and mass is in kilograms. So for an example, which you should do at home and then come to school, and we'll work on the board later, a rocket motor gives a thrust of 23 kilonewtons to a 1.7 ton satellite. So you have to calculate the acceleration. So just pause the video and work through that at home. Okay, so finally we have Newton's third law. We've gone through the first and the second, so the only one left, of course, of the three laws is Newton's third law. It's probably his most famous. For every action, there is an equal and opposite reaction. You see that in the classroom, of course. When I give you homework and you don't do it, you get detention. So the opposite reaction for doing no homework is, of course, the Friday detention. Here's example, we have the rocket motor here, spiraling into space. So, bit of chemistry, you've got the combustion reaction of all the nitrogen oxide compounds and oxygen. This produces a force from the exhaust gases, which is the action force, and the reaction force is the thrust force of the rocket, which accelerates it forward into the deepest, darkest positions in space. And that is Newton's 3 laws.